Here's an example of solving a circuit problem, and this one comes from the textbook. It's example 2.8. So we're asked to find the unknown current I0. So the first thing that I should do when analyzing this circuit is identify where the nodes are. So step one is label the nodes, and there's 3 of them. Can you see them? So the first node would be over here. I'll call that A. Next node is B over here, and we should recognize that node B extends kind of all the way across here. So that's node B, and the final one would be node C down here. Step 2 would be to use Kirchhoff's laws. Use Kirchhoff's laws to write equations. And what I'm trying to do is turn this into an algebra problem to write equations. Once I have it in a set of equations, I can then solve those equations, and that will give me the answer that I'm seeking. So if I look at the structure of this circuit, it might be quite useful to use Kirchhoff's voltage law around, in particular, the loop on the left-hand side, because I've got a voltage source. So Kirchhoff's voltage law is nice for loops like that. But if I'm going to do that, then I need to label some voltages that are in my circuit. So in particular, I might label V1 would be the voltage across this resistor, and there will also be voltage across this resistor, which is the same as the voltage across the current source, and I will call that V2. So with these things labeled, I can now start to use my Kirchhoff's laws. So for instance, I can do Kirchhoff's voltage law at loop 1. Loop 1 is here. Loop 1 is this one. So Kirchhoff's voltage law at loop 1. So again, I'll start at the bottom side, so that's kind of an arbitrary choice, and I'll go around in clockwise direction here. So starting with KVL on loop 1, I would say approach the voltage source 120 volts from the negative side, so that's minus 120. I then approach V1 from the positive side, so that's plus V1, plus V2, and then I'm back to where I started. So I'm just doing this loop just in here like that. Plus V2 equals 0. So that's the first equation that I have written down. Now I can use Ohm's law to get this in terms of I0, because that's what I'm really trying to solve. So I also have, by Ohm's law, I have that V1 is equal to 10 times I0. So I can write that one down and substitute it in straight away. So this would give me therefore minus 120 plus 10 I0 plus V2 is equal to 0. So I still have this V2 as an unknown parameter that I need to try and eliminate from this equation so that I can solve for I0. So and next thing that I need to do is write down some more equations. I need to further analyze this circuit. So I need to use Kirchhoff's laws again to get me another piece of information. So in this example, it seems like a nice idea to analyze the currents that flow into node B. And that's a nice idea because I have here this current source where I already know that there's 6 amps flowing. And also I have the parameter I'm interested in, I0, flowing in. So therefore, I think that Kirchhoff's current law would be a good tool to use here. So if I would like to use Kirchhoff's current law, I will also need to label what is the current that's flowing through this resistor. So I'm just going to label here I1 will be the current flowing down. So now I can use Kirchhoff's current law, KCL, at node B. And so I would have that the sum of the currents flowing in, so sum of I in equals the sum of the currents flowing out. Sum of I in equals sum of I out. So currents flowing in this case, would be I0 and the 6 amp current source, and the currents flowing out would be I1, my unknown value. So this is good. We're making some progress here, but I need to relate my V2, which is my unknown over here, with my I1, which is the unknown over here. So I've got a voltage and a current at the same component. So this is the voltage across the resistor and the current through that resistor. Well, that's pretty good news because I can use Ohm's law here. So by Ohm's law, what I will have is that V2 is equal to 50 times I1. Rearranging that gives me that I1 is 1 over 50 times V2. So now it's basically an algebra problem. So I will substitute for I1 in my equations. So I'm going to call this one here equation number 1, and this one here I'm going to call equation number 2. So substituting into equation 2, I will get that I0 plus 6 is equal to V2 divided by 50. So this now tells me that I0 is equal to V2 divided by 50 minus 6, which means I can substitute back into equation 1. But actually this will be a little bit easier if I solve for V2. So let me just rewind that for one moment. What I'm going to do is solve for V2 so that I can get directly to my unknown current I0. So solving for V2, multiply 50 on both sides, so that's I0 plus 6 is equal to V2. So now I'm going to substitute V2 into my equation number 1. So substitute into equation number 1, and that gives me minus 120 plus 10 I0 plus V2 is, using equation, I'll call it equation 3. So using equation 3 here, that gives me 50 times I0 plus 6 is equal to 0. So now it's an algebra problem because I now have only one unknown. So let's work through this. So I will expand the bracket, so that's 10 I0 plus 50 I0 plus 300 is equal to 0. Then I will get, let's bring the I0s together, so I will have 60 I0 plus, so this will be 180 is equal to 0. I0 will be minus 180 divided by 60, so 18 over 6 is minus 3 amps of current, which will flow. So I0 here is minus 3. So let's go back and look at our circuit. So the minus in this case just means that the current is flowing in the opposite direction. So here was I0, and we've solved that it's minus 3, so it just means it's flowing from right to left in this particular case. So the arrow's kind of drawn in the opposite direction, and hence we get the minus sign there.